So Neil, can I hand over to you to talk us through what is AI, what does it do, how does it do it, and how you can lead with it? Thank you, Neil.
Absolutely. Thank you very much, Janet. Thank you. And it's good to be with you all this evening. So I wanted to talk about artificial intelligence, and I wanted to give a bit of a historical perspective to begin with. And I want to start with one of my heroes. And I'm having that. I want to start with one of my heroes, which is this chap, which is John Kay, who was born a long time ago in 1704 in a little village called Walmsley, just up the road from Bury, where I grew up. And maybe that's one of the reasons I'm quite so keen on him. But he was an inventor, and he invented the flying shuttle, which is this device that I happen to have a beautiful one of in my hand. And the flying shuttle revolutionized the weaving industry. So before the flying shuttle, if you were a weaver, you had to take the weft, the thread, and pass it between the warp, and then move the threads up and down, and then pass it back. And it was painstaking, and it was slow, and it was back-breaking work. And I want to use this as an analogy for machine learning and artificial intelligence. Because what the flying shuttle did was to take that thread and automatically fire it at great speed between the warp, and then the warp would move in the machine, and it would fire it back again. And it did this at great speed. And so you can see one worker here in the image looking after 4 looms, all working at greater speed. And in contrast to the human doing this alone, we've actually increased the size of the cloth. We can do a broader loom. No longer do you have to stretch underneath back-breaking work. We can increase the speed with which it works, and we can increase the efficiency. So we've driven greater efficiency, one person doing more work, greater effectiveness, doing it at greater speed, and greater consistency. The thread is much more uniform. Artificial intelligence and machine learning are very, very similar in that sense that they will help decisions be made at greater speed. They will enable decisions to happen with far greater effectiveness and less human effort, and far greater consistency. Unlike humans, if you put the same inputs in, you get the same inputs out. And artificial intelligence and machine learning, I argue, will be wrapped into the fabric of our life in very many ways. Our home life, our work life. And in fact, I would argue it's like an industrial revolution. The industrial revolution is coming to an end, and the information revolution is being driven forward with data, with machine learning, and with AI. And it's helping us see new ways of working, new ways of living, new ways of being. I now have the pleasure to work for Amazon, who've got an amazing heritage. In fact, I've worked for Amazon just over 2 years, but it's about 20 years ago that I remember standing on stages talking about Amazon's examples of using machine learning to drive various things. So thinking, these are a number of the areas. I just wanted to touch on a couple. In the automated fulfillment centers, where the stock goes to be packed, to send off to people like me and perhaps yourself if you order from Amazon as well. We've revolutionized some of the leading fulfillment centers. So no longer do we have our workers moving up and down across a huge warehouse, but we have all the stock put in these great big towers, 450 kilograms of stock, sitting on top of these little orange Kiva robots. And then these Kiva robots move around. So if you imagine looking down on this scene, you've got this beautiful dance as all these robots move around in this orchestrated way to move the stock to the pickers to pick what you need to go into the orders that we may have made. Where does machine learning come in? Well, on the front of each one of these, you've got cameras to detect whether it's about to hit anything. You've got vision recognition going on to reduce the risk of injury if it moves towards anything it shouldn't hit. In terms of the battery life, we want to optimize the route for these. So we actually use algorithms to determine where should they go if they're not on the route to an immediate picker. What's the best place for them to wait, which minimizes the amount of travel that they're doing to reduce the battery usage, but also reduces the length of time it takes for them to get to someone to pick to increase the optimize the overall effectiveness. So, and there's a picture of them actually moving around. I'm amazed. So. The next best action thing, actually sitting on the Amazon retail site, if you look at that, you'll often, when you're looking at one thing, get this box come out going, well, you might want to look at these things too. There's a huge amount of machine learning going into driving that, not just looking at what you've previously bought but also looking at the sort of things you're looking at and other people who buy that, but considering too in real time what's actually available. We don't recommend products which we can't actually fulfill. There's no value in doing that. It just upsets people, leads to frustration. So think about the logic of understanding in real time what's available, your immediate recent activity on the Amazon site, the sort of interest you've got right now, your previous purchase history, and the huge history of other people who bought things. Draw that all together to provide this personalized recommendation. Hugely powerful and drives the enormous amount of traffic on the site. So stepping right back, it's worth asking, what is artificial intelligence? What did I write down on that napkin in that pizza restaurant when I was chatting with Janet? At a really high level, AI could be described as getting a computer, a system or a service to perform tasks which we usually think of as requiring human intelligence. But we can unpack it a bit more. And maybe actually to cite what we did in that pizza restaurant, I remember actually handing over to Janet a phone and literally holding down a button and got Siri to work on the phone and went, what is artificial intelligence? And in the midst of this noisy restaurant, that phone understood what I'd said and then produced an answer and explained it and described it, which is quite, it was a din, it was pizza everywhere, it was great. But actually, the ability to understand what a human has uttered, even in my dulcet northern tones, in a noisy environment, it's remarkable. And that's a use of AI. We can break AI into various bits. And so artificial intelligence is, as I've said, that ability to use a computer to mimic human intelligence, to describe something that we think requires a human to be smart to do it. There's a subset of machine learning. And machine learning is where you actually create the logic, the patterns, the models, if you will, by driving that from data. And when I was doing a PhD 30 years ago, I remember sitting down with a professor, a dental professor, in fact, trying to understand how did they make decisions around orthodontics? How did they decide what brace to fit, which teeth to move? And it was a painstaking job of me literally asking questions to get inside his head, to understand what it is that he used to make the decisions, and then figuring out how to craft a computer program using the fuzzy logic to understand the child's growth patterns, how their teeth might move in the future, understanding the forces that could be exerted and what may happen as they grow, and working out the right approach and the right result. But it was really slow, and it was really hard, and it wasn't going to scale. What is exciting is the volumes of data have massively exploded, the compute power has massively grown, and we can now get the computers using machine learning to understand the patterns themselves out of data. There's a subset of machine learning called deep learning, which is really, really massively layered neural networks. Now, about 10 years ago, this was almost a theoretical idea that people thought if we had 100 layers with complex interactions between each layer, maybe it could give us greater computational power, greater inference. But as compute power has massively grown, we've proven that they work, and they work remarkably well for vision and text understanding and voice understanding. Reinforcement learning is probably the current breakthrough research area where a lot of the really exciting work's going on. And that's the amazing area where you're kind of combining together a huge simulation device to create the data, and then using deep learning to try to actually find the patterns and create the ways forward. It's interesting because you only have to define the scoring function, the reward function. What does good look like? So imagine if you're trying to teach an autonomous vehicle how to drive, you don't have to take millions and millions and millions of pictures from the front of the car to identify what the scene looked like and then decide, do you steer left a bit, speed up a bit? But instead you define what good looks like. Something like driving smoothly, accelerating gently, going fast on the straights, slow on the bends, and slowing down if something's going to be in the way. And then simulate huge amounts of data and use deep learning to identify the ways forward. Over the years, there's actually been some amazing breakthroughs, and these two charts actually represent that. On the left, object detection, the ability for a computer to understand the scene and see what's in there, has broken through human performance. And on the right, understanding the recording of a call center, what's the agent saying, what's the caller saying, and transcribing that word for word in real time. speech recognition algorithms have now matched and are probably about to break through human performance. Isn't it interesting the human line is not getting any higher? We're not getting better. As the years go by, our generations go on, humans' performance at these tasks won't really improve, but the computers will. They will get better and they will improve as the years go by in many different areas. So Amazon Web Services is providing services right across all these different areas, just to give a few ideas. And thinking back to that weaving analogy, we've now got the abilities for, instead of people receiving bits of paper, forms filled in, why not use the ability to automatically analyze what's on that document, extract text out of the image of that, convert that into data and put it into things. We've got customers using voice to generate lifelike speech. In fact, the environmental agency give warnings, flood warnings, at a really hyper-local level, using very realistic voice technology to just describe it as though someone was talking to you. We've got capabilities to forecast what will happen at local level. So utility companies are forecasting individual customers' patterns of usage of electricity and gas, right across all these different areas, huge capabilities. It's also really exciting, having been in the field for 3 decades, to see it breaking through into reality now. We look across a number of organisations and start to realise that many of them have moved beyond beginning to experimenting. They're starting to do kind of experimentation with machine learning, using different techniques, seeing what works. And a few of them are kind of stepping into productionizing, where actually their business depends on the inferences coming from AI and machine learning happening in real time, part of that where they're up to. It's still true, however, that few have really moved into leading, where machine learning is a fundamental strategy of how they run the business. And they have a coordinated approach right from the chief exec down the top level, governing it properly, stewarding the data to get the most out of the asset, and asking every area how could they get business machine learning to infuse that business. There's a few at the right, but I think the winners will be the ones who actually get to the right quickest. Interesting to ask, what do you need to do to get to the right? And we're seeing kind of patterns. There's probably 3 key pillars that you need to work on to move to the right. And the first one is getting your staff, your people, to get the skills, to develop the understanding of how to do this capability, how to use it, to get that abilities there. Operations, how to actually understand which business problems to solve, and how to feed that into the business and process that you've already got. And really at the bottom, underneath all this, is getting the right kind of technology. And the cloud and the abilities to use AI and machine learning frameworks in the cloud have made that massively more easy to adopt. Going back those 30 years to be creating an expert system, as we called it then, to predict orthodontic treatment and plan that, a lot of that was handcrafted. Now, you could go so much further, so much more quickly, because of the capabilities that are there for people just to pick up and use. I'd like to give a few examples of how this is used by different people. So Axial 3D are an amazing partner. They're over in Ireland, and they actually make little models like this one. If I could hold it up to the camera, this is a model of vertebrae within the spine. And if you look right here, you can see within this bit, there's a growth on the vertebrae. And what they're doing, they're in the business of helping surgeons prepare for surgery. So they take MRI scans or X-rays in great detail of a patient, and then they convert it into these 3D models and actually allow the surgeon to plan, how will I go about this surgery? Obviously, surgeons, they operate in 3D. They're very tactile. They use knives to cut things, break into skin. They don't really operate on the screen. So give them a real model that they can start to pull apart, they can investigate, they can plan the surgery, they can get the whole surgical team around it. They're actually seeing huge breakthroughs in reducing the time the surgery takes and the outcomes and lives being saved, because surgeons can plan complex surgery in advance. And Axial 3D are using machine learning in how do you convert that complex fuzzy image that's come out of an MRI scan into something to produce a crisp image like that. A much more fun example is maybe Tinder. So Tinder are a customer, they're using Amazon SageMaker, a machine learning platform, to create the matches to recognize who you might want to recommend as someone to pop up and then go swipe left or swipe right. Now, personally, I've never actually used Tinder myself, but I'm told it's got a premium service where you can improve the quality of the matches. And now one of the intriguing things that Tinder are doing is using our vision product called Recognition, where you upload your photo and it will analyze the photo and look at you and study not your face necessarily and what you look like, but what's in the background. Actually, have you got books in the background like I have, or have you got plants, or are you in a restaurant, or have you got a sporting area, are you outside, are you in the garden? And they're basically creating extra attribution about you based on your profile picture, and they're using that in order to help improve the matching. They feed that into the algorithm and use that as a matching. I think it's a really clever way, but it also speaks to how data isn't just the rows and columns. Data's video feeds, audio feeds, images, huge amounts of data. Another brilliant case study which has recently come to light is Beewise. And Beewise have focused on a fascinating problem, a really real world problem, that actually 71% of all the fruit, the vegetable, the seeds and nuts that we eat, that we need for our lives, are actually pollinated by bees. And yet bees are suffering. In fact, 30 to 40% of all the bees die every year. And it's really hard to understand why and what's going on. And yet we look after them with a 150-year-old technology of a wooden box, a beehive. So Beewise have studied this and have created an IoT sensor-based new beehive, complete with cameras that track the bees in real time, and then using neural nets and machine learning technique to understand the health and vitality of each individual bee in order to provide back feeds to the beekeepers. So the beekeepers have their own kind of apps and they can track in real time the health of the bees, and they know when they need to go and visit, and they know what it is they need to do when they go there. So we're transforming something which was a back-breaking historic process of going to a wooden box and lifting things out to check them, to something where you've got a rich data feed telling you in real time what it is you need to do, how you need to do that, and giving you really fine control. AI and machine learning releasing the health of the bees, in turn giving us the fruit, the vegetable, the seeds, and helping us. So I just wanted to close really with the question of how do you get started? This is a get started in understanding machine learning. There's courses available. AWS, a partner with edX, Coursera, and Udacity to provide massive online learning. We've got our own certification and training that you can get. Our machine learning university is open. The same materials we use to teach our own staff, we've open sourced it, all the videos out there as well. If you go to the URL or amazon.com machine learning, quick Google, you probably find it. You see all the details of loads of courses. But we've also created some fascinating educational devices. So there is a deep lens device which combines a high definition camera with a small computer and enables you to put machine learning applications right down on the edge. So you can use it to track things like, is that my cat coming towards my cat flap and shall I open it? Or actually, I've got there's a solution architect who's gone one further and done image recognition models on the deep lens to identify, is their cat coming back carrying something undesirable like a rat or a mouse that it's caught? In which case, maybe don't open the cat flap. Leave it until they've got rid of that. We've also created the Deep Racer reinforcement learning, which is a 1 to 18th scale model of a racing car, where you can train in the cloud a deep racing model using reinforcement-based learning to actually track it around a racecourse. And then deploy that model right down onto the car, and at the front it's got a camera and it controls the motors, and your model tells it how to respond to the images it's seeing in the camera. We then have races where people race these around the track in real time against one another to see who's actually built the best reinforcement model to train this. So it's a brilliant time to start, and I thoroughly encourage you to look into how this could be skills that you can gain to change the businesses, the lives, the homes you're in. Thank you very much.